I'm going to talk about how to solve a system of equations using substitution. Now, before we get too far into it, there are a couple things I want to make sure we understand. First thing is, when you're solving a system of equations, in this case we have linear systems of equations, if you are to graph the two lines, the solution is going to be where the two lines intersect. So that is what we're always looking for, the point of intersection. And you don't have to graph the equations to find that point. It's actually a little more efficient to solve it algebraically. And one of the ways to solve it algebraically is using substitution. So here I have two equations, linear equations, that are written in standard form. ax plus by is equal to c. And we want to use substitution. So the first thing that we need to recognize is to do a problem using substitution, we need to convert one of these two, but not both, one of these two equations into y equals mx plus b, or x is equal to ky plus, oh, I forgot what the letter is. In other words, we need to get the y by itself, or we need to get an x by itself. And it doesn't matter which x or which y we use to get by itself, we just have to get one of the two by itself. So let's take a look at this equation here. My board is misbehaving, and here. Which one of these x's and y's would be easiest to get by itself? Well, I noticed that this y right here has no number other than 1. It does have a negative in front of it, which means that will be the easiest to get by itself, this y right here. So first I need to convert my equation. So first thing I'm going to do is I'm going to add y to both sides of the equal sign. So I get 3x is equal to 5 plus y, subtract 5, and then I get 3x minus 5 is equal to y. And then you could have just told me, hey, wake up, folks. It's right there. You're right. But I just wanted to show you how we converted it. Now, once we have it converted into y equals mx plus b, I can now substitute 3x minus 5 in for y. So in other words, y is equal to 3x minus 5. Now, when I'm teaching, I do not have a substitute in my room. If I need to not be at school one day, I have to call in a substitute, and that substitute takes my place. You will never have a substitute teaching when your normal teacher is also in the room, right? Just like if you're in sports and there's a substitution, one person comes in, one person goes out. So in my other equation, I have 2x plus 5. I get to that y. Well, is there another way to express this y? And there is. Y is equal to 3x minus 5. Now, a little helpful hint on this. You're really going to want to have the value that you're substituting into a new equation in parentheses. I'll show you why in a moment. And so that is going to equal negative 8. So now we are going to have to distribute this 5. This 5 is being multiplied to y, which means it needs to be multiplied to everything that is being put in y's place. So we have 5 times 3x, which is 15x. We have 5 times negative 5, which is negative 25. And this is still going to equal negative 8. And we still have the plus and the 2x. So now we need to combine similar terms. Well, we have a 2x. We also have a 15x. How many x's do I have? Well, 2x plus 15x is 17x. Uh-oh. 17 is a prime number. It's normally not a good sign, but let's see what happens. So we still have 17x minus 25 is equal to negative 8. Well, let's get the x by itself. What's the opposite of subtracting 25? Of course, the opposite of subtracting 25 is adding 25, which we'll do to both sides. So we have 17x is equal to negative 8 plus 25. Oh my gosh, look at that. Sweet.
17. So 17x is equal to 17. What's it mean when you have a number next to a letter? It means that you're multiplying. What's the opposite of multiplying x by 17? Dividing x by 17. So we're going to divide both sides by 17. And we get x is equal to 1. Am I done? I found what x is. Excellent. Oh, man. But wait. We said that a system of equations where two lines intersect. Where two lines intersect, we have an x value and a y value, right? I only have my x value. So that means I need to now figure out what my y is. I mean, I can be proactive and say I know that we have 1 comma something. But we need to take that one and we need to shove it into, substitute, into one of the two equations. It doesn't matter which one. Now, I'm going to use this equation because it's going to be easier. It's going to be easier because the y is by itself. So I have y is equal to 3. And now I'm going to substitute the 1 in for x. And then I have my minus 5. So 3 times 1 is 3 minus 5. 3 minus 5 is negative 2. So y is equal to negative 2. So the point of intersection for this system right here is going to be 1 comma negative 2. That is where the lines intersect, and you are done with this problem.